I'm going to briefly describe a couple of epistemic inquiry lessons. These are the stimulus for a longer set of lessons to do with change of state phenomena. But we start very simply with a variety of different materials that will be passed around to small groups of students, and they'll be asked to see what they notice when they feel the objects. And then they're asked to discuss and make predictions and explanations of what will happen when molten candle wax is poured onto the surfaces, what the rate of solidification will be, and their explanation of why. And to keep it very, very simple and qualitative, we would ask them choose two of the blocks. And almost inevitably, students choose wood because it feels warm, and one of aluminium or copper because they feel cold. So we're actually trying to get physical perceptions of heat to be part of the first stage of making predictions and explanations. And what's interesting in this case is this has strong confirmation because, of course, the wax does. The students reason, this is cold, the wax will solidify very quickly. This is warm, so it'll take much longer. And this, of course, is confirmed by experiment. Now, some cognitive conflict is created by then saying, well, let's measure the temperature of the two materials. And immediately, when they observe that both of them appear to have the same temperature in the same temperature of the room, it's a cognitive conflict, even though the first set of results really confirm their perception and their subjective experience. Then we move on to a similar process of saying, and usually students stick with the same two blocks of what will happen when we put ice on these surfaces. And they have some discussion, and students often say, well, this is cold. It means that ice will actually melt more slowly. This is warm, that the ice will melt less slowly. And this is a great opportunity to introduce some quantitative data. The oasis foam and the spaghetti that's to hold the ice in place can be measured before the mass of the apparatus, and then the ice can be put on. And we will let the ice and this is where you need to have some control with the spaghetti. And this immediately raises huge cognitive conflict because the ice is clearly melting more quickly on the copper, and that seems to totally confront their model. The cold feel of the copper, first of all, solidifies the wax, and it seems to be melting the ice. And I always encourage them to feel, and they feel even more cognitive conflict because the copper block feels very, very cold, and is confirmed that it has lowered its temperature with the use of a thermocouple.